Hello, this is Mary Mack. I am the Executive Director of ACEDS, the Association of Certified eDiscovery Specialists, and I'm pleased to bring you this product and service showcase for ZyLAB. ZyLAB will be introducing their ZyLAB ONE eDiscovery, and we've got with us Johannes Scholtes, otherwise known as Jan, who's the Chair and Chief Strategy Officer of ZyLAB. And I'm going to go into his background a little bit because what he's going to show you is pretty exciting and give you an idea of where he's been. ZyLAB started with ZyIndex, moved into information management and eDiscovery. Among other things, like most eDiscovery providers early, the Enron situation, the UN War Crimes Tribunals. This was technology that underpinned some of the most well-known convictions for war crimes. But it's his technical background I want to talk about right now. He's got a master's in science and computer science from Delft, a PhD in computational linguistics from the University of Amsterdam, and since 2008, which is almost 10 years ago, he's been the extraordinary chair in text mining from the Department of Data Sciences and Knowledge Engineering in the Artificial Intelligence Group at the University of Maastricht. So this is a guy who is steeped in artificial intelligence, and he's going to show how he's applying that technology to eDiscovery with the ZyLAB ONE platform. So the agenda. Jan, are you switching or should I?
Yeah.
Okay.
Well, I'm not switching. Yeah, there's the agenda.
There we go. So here's our agenda.
Yep.
So he'll show a little bit about where ZyLAB fits into the scheme of things, talk about training and certification, and a lot of the technical details. We're not going to do a demo, but he will show you screens and reports and a little bit of roadmap. The Q&A will be interactive, so if you have questions, please go ahead and type them into the question box. If it's applicable to what we're talking about in the moment, we'll interject. Otherwise, we'll save toward the end. Some admin, the slides will be available, and a recording will be available as well. So, Jan?
Yeah. Thank you, Mary. Thank you very much. Very happy to be here and to be able to show our brand new product, ZyLAB ONE eDiscovery. We worked very hard on this, and I have to thank all of our developers and testers who made it possible that we can now release this product. It's a major uphold not only of our product, but we also changed our logo after I think more than 20 years. Yeah, we did a lot of work repositioning and changing the way that all of our ZyLAB products and layout look. So what we did with ZyLAB ONE is that we integrated our information management and eDiscovery platforms. We have focused building it as a SaaS product. It can also be released on-premises, but for now we released the SaaS product first. But it can also be used in hybrid deployment models where we aim to have like one product that addresses all of the most common eDiscovery and intelligent information governance requirements. So we do have a demo. If you would like to have a live demo, then you can just request one. There's the address there in the slide, and then we will get back to you as soon as possible and show you our brand new product. Now, like I said, at ZyLAB, we focus on a number of eDiscovery use cases. The most important use cases where the largest volumes of data are present that we see are obviously in the eDiscovery for litigation and arbitration. A A very large, also evolving market is the market of Freedom of Information Acts and Public Records Acts. And then, of course, the largest and longest enduring e-discovery cases are related often to regulatory requests, competition, antitrust, bribery, financial investigations, environmental data protection, food and drugs, and also recently healthcare and all kind of other frauds. And then e-discovery is not only answering the regulatory requests, but it also related to additional internal investigations. Now, a brand new use case that we started on only just a year ago, and to focus on this one in full detail is the M&A support, and then in particular for large and complex corporate transactions. And then where eDiscovery is really very useful is for the pre-sales part of this process, where you have to collect information which you then have to organize, sort, complete, analyze, look for red flags, do a vendor due diligence, etc., before you upload the data in a virtual data room environment. This is in particular interesting with large real estate deals, life science, complex infrastructural and other type of deals where there's a lot of collateral or maintenance records for the items that you're trying to sell. So this is where we use our products for. Now, in this field of e-discovery, we at ZyLAB have always used technology from the fields of data science and artificial intelligence. And I'm very happy to see that the acceptance of artificial intelligence in general and in the legal community in particular is getting better and better. Of course, the field has been pretty old. I think the first artificial intelligence conference was almost 50 years ago, and with very small steps and a lot of failure and a lot of expectations that were set too high. Right now, artificial intelligence is actually delivering, and we see great success in this field. And we have really tried to use these tools from data science and artificial intelligence for e-discovery, and we apply it for intelligent search, data enrichment, topic modeling, of course, machine learning, and we try to optimize the use for e-discovery use cases. Now, the reason why we use these techniques is that we are really aiming for a productivity revolution. We automatically want to build search facets. We want to implement automatic redaction, document clause identification and extraction for M&A, but also for e-discovery, term and entity identification and extraction for reporting, and many more other applications. And it's these type of applications that help our users to do much more work in a much shorter time frame, but also to do much better work. Because what we see is that in reviewing these documents, if you miss a redaction or you miss certain type of privileged information, the results can be tremendous and can have huge impact and create huge damages. And we really try to, what we see in general and what has also been proven time over time in scientific research is that computers are not only faster and better, but they can work 24/7, and especially in the boring work, the repetitive work that's now manual work, computers can do a much better job. So we why did we start working on this? Now, we started working with this because the era of traditional search is really over. There's too much data. It doesn't matter how brilliant your query is. You always get too many hits. There's no relevance ranking scheme that works at best all the time. You never know what you get, and more important, you don't know what you miss. There are too many languages, too many spelling variations. There's more and more non-textual formats, images, video, sound recordings. Data is in too many geographical areas, and all this makes it that it's really searching isn't the answer anymore. So how can we make e-discovery easier? Now, we thought that the best way to do this was to use techniques from artificial intelligence and data science to add an analytics function to eDiscovery. So we make not only data sets electronically accessible, we also enrich it. So we try to enrich it with semantic information, with additional information, with links. And by using all this additional information, which can be anything from also adding OCR text to images or unplugging complex emails and doing a lot of processing, we can actually analyze, classify, and organize data much better. And by using creative and attractive visualizations along certain dimensions that are relevant for an eDiscovery, we kind of organize the data and present in such a way that the answer is more or less there for the reviewer, so the reviewer can much faster assess the content. Now, what those relevant dimensions are typically questions, common research questions that are asked in any type of investigation, whether it's eDiscovery, internal, litigation, arbitration, or regulatory requests. It's like the who, the where, the when, the why, the what, the which, the how, which means, how much, these type of questions. And then what we try to do, we try to find ways to answer these questions more or less automatically, or at least line up the data so the reviewer can find the answers. Now, we've been doing this for quite a while, and if you look at the who's then or the where's, it's pretty straightforward. You look for persons, company names. For the where's, you look for the locations. For the when's, you look for time measurements, etc., etc. Now, what we can do is we can provide different visualizations. So we can use some clustering, which allows us to show the what happened, which I show you here, which is a topic modeling algorithm, which then displays the most frequent, or the names, the most frequent labels that we find in these type of documents. We can also organize like who is there by extracting custodians or names from either from and to and mailboxes or from the text, and then build clustering and visualizations on those. We can do geo-mapping, we can do timelines. All of those we can do by either doing it in our software or by exporting data into either Excel or Palantir or Tableau or SPSS or any of these other products. But recently we thought, well, why don't we take this a step beyond? Why don't we look at like these combinations? Why don't we look at the who did what with who, or who did what why, or when did what happen? And some of these examples I show you here, and I'll actually show them to you in more detail. For instance, the when what, this is a great visualization of what we call a topic river. This is the same as the topic modeling I showed you before. And with this new, what we did is we added that we separated the data sets in weekly sets. This is almost 8 months of Reuters news from 2014. And then what you see here is that you see all of the topics. We measure how they evolve, and then we also measure how they develop themselves over time. What you see here in the middle is the invasion in Ukraine, which suddenly pushes away all the other news. Here at the right, that blue angle there was when MH17 was shut down over Ukraine. And you see that news immediately pop up. So you see also the other topics that were discussed in 2014 in the foreign policy news. This is also a great thing to run this on an email collection or on a file share collection. And it's just one example of the different data science. This is another one that I want to show. What we did here is we took 220,000 song lyrics and we mined them for 6 basic emotions. Computers are really good in emotion mining and sentiment mining. So here we looked for words and patterns that are language that's related to trust and anticipation and joy, anger, fear, and sadness. And then what you see is that the top right, you see that's where typically all the pop music stars are, like Elvis and rock and roll and the Beatles and David Bowie. And then on the left, you see all the rappers. In the anger there, it's 50 Cent and Eminem. And then I always tell my children that Justin Bieber is in the middle, which kind of shows that he's truly confused. Well, anyway, so this is another example of how you can measure, for instance, who does something why. because often the why is strongly related to emotions. Now, what we're going to continue to do is in our new platform, the ZyLAB ONE eDiscovery platform, we now have the ability to add these type of analytics very easily. So in the next couple of months or the next years, you will see many more analytics that we will continue to add to our platform to help our investigators answer questions as easy and automatically as possible. And then these two examples I showed you, of course, are some toy examples with some toy data sets, but we will continue to add these for really real-world e-discovery use cases, M&A, FOIA use cases, or regulatory request use cases. Now, with ZyLAB ONE, we have a very strong focus on SaaS. Already 25% of our clients are in SaaS, in our SaaS platform, and we see that the percentage of customers interested in SaaS is only increasing. We did a special webinar on that with ACEDS, which a couple of weeks ago, for which we still have the recording available for download. And that's very understandable, because e-discovery in many cases is like an incident. It's something for which companies do not want to invest very large strategic IT resources, also because it's pretty unpredictable in nature. And SaaS is a natural fit, because if you need it, you just use all the computers you need, and then if you don't need it, you shut down the system and you don't use it until you need it again. Now, with ZyLAB ONE eDiscovery, it's our second generation SaaS, where we have focused a lot on self-service, easy onboarding, and we've tried to increase the levels of automation so the user can do as much themselves as possible in management, data collection, data processing, early case assessment, review acceleration, etc. And what we do is we've also added a lot of management functions, monitoring, updating, and reporting. The really great thing about ZyLAB ONE eDiscovery, the SaaS, is that this new platform, because it's also a single-tier multi-tenant environment, we can also add new functionality on a bi-weekly basis. And so this will allow us to add new features very quickly. And we don't have to, the customers, of course, don't have to upgrade, and they don't have to wait for a new on-premise installation. And this will allow us to do a much faster development speed. Now, of course, we will continue to supply on-premises installations as well, or hybrid installations, where part of the system can be in the cloud, or in your own private cloud, or in Microsoft Azure. Because we expect that in the next 5 to 10 years, we will probably live in a hybrid world. There are still many clients that do not want to store their data in the cloud. They want to do everything on premises, although the number is getting smaller and smaller. But there are clients that have multiple clouds, or that have very, very confidential data that they prefer to keep on premises. And therefore, we're going to be able to use these hybrid installations. And with these hybrid installations, we're going to deploy probably every 3, 4, 6 months a full new on-premise installations, and we'll do hot fixes and service packs in the meantime. Now, this new product also has allowed us to work strongly on a relationship with Microsoft and made a much tighter integration. The first integration is on Azure. I'll tell you about that in a second. But we can run our software in Azure. We can also upload information to the Azure block very, very quickly. So the Azure block is the most efficient and fastest way to get data into the cloud. And we can benefit from the scalability of the Azure environment by easily allocating more machines. We also have a very tight integration with Office 365. And then, of course, we can still connect also from Exchange and on-premises installations from SharePoint. Now, why is this important? Why have we chosen for Azure? Now, Azure has a couple of benefits. The most important benefit from Azure is that it is very easy to scale up. And this is important for eDiscovery, as I said, because with eDiscovery, you never know in advance how much data you will have, what type of data you will have, and what type of processing is needed. And therefore, you need some kind of intelligent load balancing and resource allocation that prevents you from bottlenecks and that actually allow you to deal with the data wave in eDiscovery. The other advantage of Azure is that Azure guarantees that the data is within a certain jurisdiction. So it's within the United States or in Canada or in Germany or England. And so you know for sure that your data is not going to leave the jurisdiction in which it has to be. Now, this is very important for international companies that do not want their data to be in the United States. Microsoft Azure is one of the, or the only of the big cloud providers that guarantees this, and this is why we decided to work with them. How can we scale up? Now, what we did is we created some scripts. So with a script, we or you can create an Azure environment very easily. This means that you tell the system, I want, for instance, 9 processing machines. I want 1 SQL server. I want 5 review servers to host like 50 people. Then this environment is created automatically in Azure. In Azure, we also can deploy images from our software, and it's very easy, just an hour or so, to finish a full installation of the ZyLAB software in the Azure environment. Now, next, what you can do is, if you don't need all those computers, you spin them down, and then the major advantage of Azure is that you don't pay for it. And then if you need them, because you have a huge eDiscovery project, you spin them all off, you do all your processing, you make the deadlines, and you spin them down again. So it's very, very flexible, very cost-effective environment. The other thing which Azure does is that it allows us to provide high availability. Suppose you want to have 99.5% availability because you don't want your review teams to sit around and do nothing. Then we can guarantee that with Azure by using 2 data centers. One which is online and the other one which is standby but being updated all the time. And then whenever something goes wrong in one data center, then we can automatically switch to the other one. And this is also very, very cost effective in Azure. Now, you can ask yourself, okay, Microsoft also has eDiscovery in the Microsoft E5, which is absolutely the case. So what does ZyLAB add to Microsoft's eDiscovery? Well, first of all, let me tell you that Microsoft's E5 is a great product. It's great for culling and for taking data from the 365 environment. It has some great machine learning in there, and you can very quickly cull a lot of data. But there's a couple of limitations. First of all, if you have on-premise installations and you don't want to upload everything into Azure or into the 365 environment, then with ZyLAB you can do collection and processing and first-pass review in a hybrid environment. We offer perpetual licenses, which can be deployed either in Azure but also on-premises, which are non-volume based, so you don't pay by the volume or the mailbox. We can do direct collections from other sources. We can collect from many different sources, content management systems, all kinds of repositories, without first having to load the data all in 365, which can be a huge bottleneck. We do deep processing to find more information, support more file formats. One of the file formats that Microsoft does not recognize in E5 are automatically copied to the review, so you cannot reduce that data by automatic culling tools. So if you do have a lot of file formats or complex file formats or compound file formats that are not recognized, then you're going to do a lot more reviewing. And then, of course, the most important, we have a review interface, allow for auto redaction and pseudonymization. We support multiple file formats. We do audio search, entity extraction, text mining, machine translation. Now, all of those are also available in Azure or in Microsoft, but they're not fully integrated. And we have integrated them very easily with our technology. And if you use our software in Azure, then you can use all these integrations, for instance, the machine translation, just by paying for your usage. We've developed a lot of training material, online training for a lot of different aspects of our product. With this training, our users can also get certified. So if they have completed all the trainings and answer a couple of questions, do a small test, they can get the ZyLAB ONE certificate. And that slowly brings us to the technical and architectural information. What you see here is a more functional overview of our platform, and seeing the different deployments and the different parts of the EDRM model. What I have here is a more technical architecture. So what you see here is that we can have multiple tenants, but all these tenants run on one tier. It's one installation which has a public API and SDK. The entire interface is HTML5, which has a number of huge benefits, which I'll show you in a minute. Then there's very strong user management and security according to all of the international standards. And then we have all the different functionality. We have the admin, the review, production, matter management, reporting, data uploads, alert notification, technology-assisted review. And then everything can also be backed and restored, and there's disaster recovery all under the hood as part of the Azure service level agreement.
Yeah, we have a question on security.
Yeah.
Around collection methods, and that collecting from SharePoint sometimes needs admin access, and how that's handled.
Yeah. If you want to directly collect from SharePoint and other resources, you are absolutely correct that you do need admin access. So if we don't have admin access, we cannot, or at least we need to have access to the mailbox or the projects that a user also has access to. If we don't have user access, then we cannot collect. But we do not need admin access per se. So it must be like a user with enough access rights is also enough. And that's the same way how we collect from social media. We need to have the passwords, and then we can the user IDs, and then we can collect from those. Is that answering the question, you think?
Yeah. So no God account necessary. No, overall
no,
super admin or anything like that.
Not that I'm aware of. No.
Okay. Very good.
Okay. So we are using a microservice architecture. You already mentioned our old product, ZyIndex, Mary, of which we sold 600,000 copies, going all the way back to many high-profile trials. But this was like a traditional monolithic software, which kind of, if you wanted to change something, there was always a risk that you would break something somewhere else. Now, over the years, we started using different development techniques in the computer science world. And one of them was the service-oriented architecture using a bus structure, which you can see here, which made it easier for us to separate different functionality. And a change on the left side did not immediately affect some kind of functioning tool on the right side, but there was still a big risk that you would break something. Now, what we have used for our product now is a microservices architecture, where we create these independent microservices that do one particular small task with a well-documented API around it, and then this allows us to make changes much easier without the risk of breaking everything down. And the microservices is really the way forward in computer science right now, and it will allow us to continue adding functionality without creating something which is no longer maintainable. Okay, starting from the beginning, do-it-yourself self-service. We have created this functionality so when you're a small law firm and you want to do a case, you can actually upload the data yourself in PSTs or zip files, whatever you want. You can add custodian names, add some additional information, and the data is immediately processed in the back. And this is a huge benefit because you don't have to wait for some kind of other party to process the data or to deal with the data. You upload it, and already a couple of minutes after the initial upload, there are documents ready for review. And not everything will be ready. That depends on the number of processing units and the amount of data that you upload. But I've seen cases where law firms uploaded 200-300 gigabytes overnight. They came back the next morning, 7:30, everything was ready, and they could start their review. So it allows you to start working on the project with very little time between the moment you have the data and you want to start working. And that's very efficient, and this is one of the things we try to do with our data science and artificial intelligence technologies, that we want to make the time frame between the identification and collection of the information and the automatic the review of the data as short as possible. Okay, HTML5 looks very good. The benefit is that it automatically scales on all kinds of devices. So yes, we do have an iPad version now. We have an iPhone version and every other mobile phone on the market with a browser. But also we can use one or two screens, and then depending on the size of the screen, the software will automatically scale. It's also giving us a lot of advantages, so we can also translate the interface. We can also deploy different wording and lingo for different applications. So for a law enforcement application, we can use different language in the interface than for a legal review application or from an M&A or FOIA application. And it's the same software. A very nice.
Since you're talking about languages, this is a little bit different than the interface that you can change and localize. But your sentiment analysis, is that in multiple languages as well?
Yes, we have this available in a number of languages, but not as much as like for indexing and OCR. We support almost 400 languages. For sentiment analysis, it's more common languages, but it is if somebody has specific language requirements, it is very easy for us to add that in different languages. So. If you have a specific request or application, we can discuss that.
Thanks, Jan.
Yeah. Okay, but you're right that sentiment and emotion mining is absolutely language dependent. But it's not as hard as some of the other linguistic dependencies that you sometimes see. So there's a great once you see these facets here. These facets are actually automatically generated in our software, so the software automatically classifies the data, not only by easy categories like users or location or file type, but here we can also recognize, for instance, the emotions or the sentiments, or is there anything which is indicating some antitrust behavior, or is there like a one-on-one email, or is there email to certain online shopping, e-commerce sites? Is there a typical type of spam email? Now, all of these categories, we try to recognize them as automatically as possible, and then present the data in facets. Now, you can also create your own facets, and you can have as many facets as you want, and then by clicking on one of these facets, you can either drill in on them, or you can take a more traditional view, which is what I'm showing here, which is a view of just a tabular view with different fields. Next, of course, you can open the document, and then you see all the same functionality we had in our previous environments, but then it was only available in Silverlight, and now this is all HTML5. You can see the email threading here on the top left, including a red line for the missing emails. We can store up, hundreds of document properties. We show the whole family of documents. We can show near duplicates. We can do the tagging. Very popular these days. We can do the auto redaction or manual redaction, including putting some text here, which does not only allow you to put the rule of the redaction there, but also, for instance, to add a pseudonym. So, and this is important in the upcoming new GDPR. For instance, if you have a subsidiary in Germany or France, and you want to collect information from those subsidiaries for a US regulatory request as of 18 May next year, 2018, and already in Germany and France right now, but in a couple of, in a year from now in the entire European Union, you are no longer allowed to do that unless you redact all the information. And this is not just names and PII, but also all kind of other personal information like political preference, religion, etc. Now, with ZyLAB, we can recognize these type of patterns automatically. You can change that yourself, and we reach very high levels of quality in this redaction, and it's a huge time saver. We've seen ROIs of really 100 to 1,000 times faster compared with manual redaction.
And so, Jan, you're saying you can put the redaction reason and also custodian 1, custodian 2, custodian 3, something like that?
Yeah.
Excellent.
Yeah, and that's actually what then the authorities can look at the data, and if they then think that custodian 1 is doing something illegal, they can then request the name of custodian 1, but you're not going to give them all the names beforehand. Yeah. Now, to make it easier, we have added context-sensitive help, videos, help files, online, everything to help the user to explain how the software works. And then our latest and greatest, the first part of our data science platform, or the data science component of ZyLAB ONE eDiscovery, where we've added the machine learning. What you see here is an overview of an issue which has been trained, where the way how we work is that we show the system a couple of documents, and then the reviewer text them as relevant or not relevant, responsive or not responsive, and then we build these different cycles. We show the progress of the machine learning and the classifier. So what you see here at the bottom is the process of the training process. We also analyze the quality of the return set. We do 11 points precision recall, all the best practices used in machine learning that has been around since this business, or since this as defined by the Tax Retrieval Evaluation Conference, which is always initiated by the National Industry of Standards, which has been around since the 70s. And by using these different techniques, we try to create a defensible process. We can start the TAR by using search, but we can also start the TAR by using topic modeling. What you see here is a clustering of a large Reuters data set of 800,000 documents, and then we automatically recognize different clusters, and then the user can identify one of these clusters and then start the machine learning with the most relevant documents from that cluster. We support different TAR protocols as they are as they have been kind of defined in practice. So we can either start with a random set, or we start with search, or we start with topic modeling, or concept search, or clustering, different names for the same thing. And we also can combine them, which to my knowledge has been referred to as TAR 1 to TAR 4. And so actually we're doing TAR 4 because we combine all these different models, and then we can also do it with or without a validation set. So it's very flexible machine learning. Okay, yeah. And if you want, there's actually a video on our website. Yeah, sorry, go ahead.
Yeah, and we had a webinar where on automation where one of the presenters was pretty negative on the state of TAR for accuracy, being able to validate. Can you talk a little bit about that?
Yeah, well, what we there's different measures. There's accuracy, and if you define accuracy as in machine learning, that accuracy is not what we're using. We're using precision and recall, and accuracy is a measurement in machine learning, which is used to define how good the classification is. But for instance, if I would do a very small search and I would make sure that all the results are in my result list are good, then I could claim a very high accuracy, or I could just make sure that I don't find anything and I can also claim a high accuracy. This is why we came up with precision and recall. If you're interested, you can look up the specific detailed differences between all of those also on Wikipedia. They're greatly explained. And with precision and recall, we measure them both at the same time. So what we do with our systems, we are constantly looking for systems that have at least 80% precision and recall, and typically we would agree, or parties would agree, on 90% precision and recall at the same time. Now we see that for certain type of machine classification tasks, that can be achieved very, very quickly, already after 100 or 200 documents that are reviewed. This accuracy or this precision and recall is obtained. Now, the human performance in general is not higher than 80%, and a lot of humans perform lower than 80%. There's been a lot of scientific research. Maura Grossman has done a lot of work here. But also, if you go back in the track history, you see that people in general don't perform better than 80%. So by having these systems at 90%, we are already doing a much better job now. If you want to do more, you can always do more, and you can always measure the quality of these systems. Now, if you constantly measure the quality of these systems, you can go on until you are satisfied, and maybe you want 95% of quality. And this is very easy because instead of having to do everything manually, you can have a lot of the work done by the computers and only do the reviewing and the testing by humans. Now, if you use sampling for the testing, you don't have to check 100%. You can also check 5% or 10%. Then you're allocating your resources even better. Now, there are certain cases where machine learning is not working. For instance, if you have many different languages, or if you and you don't take that into account in the training, or if you only have numbers, or if you have very long documents which discuss many different topics, or if the decision why a document is responsive or not is depending on just one small phrase. Now, in those cases, machine learning is not the answer. In those cases, search is a much better solution. So it kind of depends on what your application is, but in general, machine learning is better, faster, and more cost-effective than any human review.
Yeah, thanks, John.
Yeah. Okay, there's a video on the whole process and the benefits where we actually do go until 100% precision and recall. And then we do that 20 times faster than manual review. So instead of using 20 reviewers for a very long time, we only use one computer and one reviewer, and they win with flying colors. Okay. So what does it tell us, the dashboard? There's a couple of slides here. It tells us the quality and the progress of the machine learning process. You can actually see the whole development, and when you use a validation set, you can also make an estimate of the total number of documents that are relevant in the data set. So you know when you are at 80 or 90% recall, you know when to stop. We can also look at the return set and look at the precision of the return set, and then you see that it typically first goes up. And then, because as the system progresses, there are less and less relevant documents, it will probably it will go down. And then when the return set hits 0 again, you've probably had everything. And you can also use the 11 points precision and recall where by trying to aim both the precision and the recall in that upper red corner to be 90%, if that's what you're aiming for, then you have to continue your training until your training has reached that stage, and then you have a pretty reliable classifier. Okay, like I said, this is a test, real-life test where we had to classify 1.2 million documents into 15 categories or classes, and then you can see here that in this case we did it much faster with one person and a computer than with a whole team of manual reviewers. Now, in general, the results of the machine learning, which we do not only use for classification and predictive coding and typical e-discovery search, but we also use it a lot for boosting the recall in the search process. Because one of the other major benefits of predictive coding is that once the user has identified 20 or 30 relevant documents, then the computer can start searching in the background and present other documents. And as a result, the user does not need to know some very complex technology to define queries. And you see some samples here of some examples. The red line is actually the category sports from Reuters, and you see that it goes straight up and it learns very quickly, and there's no decay in the learning slope. But the other one, the blue one, is war and civil war, which is a little bit more vague category. You see at a certain moment that the speed of learning kind of slows down. Now, if this is typically the behavior in machine learning, and you can also measure when you expect that this slope will actually change. And therefore you can predict how long it will take to reach a certain quality level of the classifier. And again, this is all checked by sampling by humans. So there's a constant quality control running in the background, often much more and much better than it is with manual review, where if you have to simulate this, you need to have like different groups of reviewers all checking each other and then also evaluating all the different differences. Now, with a computer, that's much faster to do. Now, in this TAR, how can we trust artificial intelligence? How can we trust machine learning? Which is a very important question, because using technology in the legal space without validation and defensibility taking into consideration is very risky. So we have this defensibility reporting. So once you hit the classifier reached a good enough quality, which you can define yourself. So say that we hit this 80%. Now I want to push the red button and classify everything automatically. At that moment, we can do additional sampling by an independent party who can then determine whether the data, the classifier is really good. And we can also generate a defensibility report, which contains all the details of the training process. And that can then be archived for later purposes whenever somebody questions the machine learning process. And this includes the training documents, which reviewer, how they reviewed, how long it took, but also all the technical details of the classification process. We worked a lot on reporting. We have much more flexible reporting and production, different types of reports, inclusion and exclusion reports. We have a chain of custody reports. We have extended auditing and process control. I'm going pretty quickly through these, but these are the more interesting ones. This is a really nice report that we did as part of our M&A, merger and acquisition data room preparation use case, where we can analyze the content of contracts, so we can recognize how many agreements there are. Are they NDAs, commercial agreements, employment agreements? We can recognize the jurisdiction. We can recognize the locations of the parties. We can recognize currencies and all kinds of additional information which we then present to the users. Now, this is great information if you have to do a due diligence or a vendor due diligence, and you wish to kind of assemble the team that you want to do the due diligence. Then you can have this team depending on what you need and how many resources you need, you can make a much better estimate after this report. This report here is a second example. This is where we have analyzed the content of the agreements. So we look at whether there's change of control clauses, are there indemnification, all the typical things that you look for in a vendor due diligence or in an M&A process, which could delay the sale of an asset, and then we can even extract the values and show those. Now, this is something that M&A lawyers like to use to discuss the progress of review and preparation of data rooms.
Was that a listing of contract clauses in an Excel sheet?
Yeah.
Okay.
Sorry. Yeah.
No, yep.
No,
that's a good thing.
We can. Yeah. No. So we can export those to Excel, but we can. The first ones are in our products. These are, and there's a couple of other different tools, but these are some really great tools to. If you, for instance, want to make an assessment of different change of control or indemnification clauses or exclusivity clauses, you can immediately see, okay, what's the text in there? Do we need to, how many, is it complex? Is it different? What kind of action do we need to take? So it gives you a summary of what's in these contracts. Now, this is another example where we, for instance, this is an example, we had to anonymize it, but this is from a real estate data room where there were different objects, different buildings, and for each building there had to be a different type of agreements. There had to be a lease agreement, a purchase agreement, a valuation report, a mortgage, and then by looking at these data sets, we can very quickly see what information is missing. So this is very relevant to very quickly build a complete data room. And instead of having to do this manually by comparing it to templates, we can automatically identify these different parts that are missing. Okay, so what to expect in the near future? We're going to do bi-weekly release cycles. So we're going to add lots of new functionality. On a regular basis, we're going to build an on-premise release probably every 6 months, and then also service specs and hot fixes when that's needed in between. We are going to put a great focus on data science because we believe that analytics are the future for eDiscovery. It's necessary to keep up with the data volumes and to add more productivity. And our focus is to try to build relevant analytics for eDiscovery, which are around the dimensions and the typical questions that our users ask most in certain use cases. So they can kind of semi-automatically, we're trying to answer the questions by lining up the answers and then put it in a very useful visualization on the screen. We're going to do more online training. We're also going to organize workshops. And one of the things of this new release is that we actually have a ZyLAB community where you can go to and you can sign up and you can keep yourself updated. There's training material, there is ebooks. This is also where we will build up our ZyLAB Trust Center, which will contain documentations on everything you wanted to know on the security for our SaaS to the defensibility of our artificial intelligence algorithms and how it works. And this is also where you can share information with other ZyLAB users and also talk directly to our consultants and support engineers. Okay, that's it, Mary. 5 minutes before time.
Wow, Jan, that's pretty impressive. Hey, we've got a question about mixed languages when you're doing machine learning, artificial intelligence. What is the effect of a document that's partially in German, partially in English?
Yeah, well, it will not be classified as good as a document that's fully in German or in English. But the final effect is hard to predict. because it depends on also the general word distribution within one language. But if you have just a little bit of German in a long document, it's not a problem. But if it will absolutely be a lower quality in classification. So the best thing to do is either to use machine translation and translate it beforehand, and then only do the machine learning on the translated documents and then fall back to the German document, or that's something which where you have to separate the documents and do more a machine learning on a paragraph-based level than on a document level. But that's causing all kinds of other problems.
Okay, well that's great. Well, this is quite an upgrade. And in full disclosure, I used to work with you for some time, and so I saw the product previously, and this is quite a leap. Please,
thank you.
As you said earlier, congratulate the developers, the designers. Looks beautiful. The reporting people, thank them.
I will.
Just a reminder, you will get the slides. You'll get a link to this recording. And at the beginning of our webcast, there was a slide for requesting a demo. And Jan, is there an email address if people want to just send an email over to you and request a demo? Should they use Annalore?
Yeah, they can send it to Annalore, or they just send it to info@zylab.com, or they go to show the slide again.
Oh, there we go. There's the live demo slide.
There's a contact form, and it's very easy. Just request a demo on the contact form.
Exactly. Well, I'm going to press that button myself, Jan, because I want to see it, and I want to see.
There you go. There you go.
I like the live versus the Memorex myself. So, well, Jan,
absolutely,
I want to thank you for a wonderful webinar, and I want to thank our community for their kind attention and great questions. And if we've missed any questions, we'll make sure that you get them, Jan, so that you can answer them directly. They're all recorded in the notes of the session. So with that.
Thank you very much,
and have a great afternoon.
Okay, bye-bye.
Bye-bye.